Morning students, welcome to session 2. Here we are going to learn in detail kinetic energy as well as potential energy. So let us start. In session number 2, you will be able to learn kinetic energy, its definition, derivation, and some examples, as well as potential energy, its definition, derivation with some examples. Let us begin with the first one, that is kinetic energy. In this slide, what you can observe? Exactly, that is a moving fan and moving swing. So it indicates the word motion. So yes, so the energy due to the motion is called as kinetic energy. So that is the definition for our kinetic energy. The energy possessed by an object due to its motion is called as kinetic energy. Now let us derive the equation for kinetic energy. In the previous chapter, motion, we have already studied there are three types of equations of motions. Among that, we have to select the second one, that is v square minus u square is equal to 2as, where v is the final velocity, u is the initial velocity, a stands for acceleration, and s stands for displacement, where we require displacement. So here if we check the second step, the displacement is written in the form of v square minus u square divided upon 2as. Now as we know, force is written as the product of mass into acceleration. So the value of the force that we are going to substitute in the third step is equal to mass into acceleration. Now as we know that the formula for work is force into displacement. So here you can observe force is written as mass into acceleration and displacement is written as v square minus u square upon 2as as we derived earlier. Now here this acceleration from denominator and acceleration from numerator get cancelled. So what will remain? Half m multiplied by bracket v square minus u square. Now if the object is in the motion, so that its initial velocity will become 0. So here we are going to substitute the value of u is equal to 0. So this gives an equation w is equal to half mv square, where v is the velocity of an moving object, m is the mass of an object, so that the work is written as half mv square. But we know that, as we have learned in session number 1, that energy is capacity to do the work, and the work is done by the moving object. Hence the energy is kinetic energy, which is responsible to do the work, and hence it is written as kinetic energy is equal to half mv square, where kinetic energy is represented with the letter capital E and the K. Now the SI unit of kinetic energy will remain same as that of the energy, and that is the joule. So what we have to remember from this slide, the mathematical formula for the kinetic energy is half mv square. Now what we can observe from this slide, the arrow is moving away from the bow after stretching. So while you are stretching the bow, it possesses some potential energy. So while you are stretching, due to its elasticity, it possesses some energy. And the energy due to elasticity is nothing but the potential energy. And when you release it, the arrow starts moving. In the second example, we can observe that it's a spring which elongates as well as get compressed. With the help of some force, you can compress the spring as well as you can elongate the spring. But before compressing or elongating, it possesses which amount of energy? It possesses the energy due to its elasticity, or we can say energy due to its configuration, and that is the potential energy. Correct. Now let us discuss the definition of potential energy. What do we mean by potential energy actually? So the energy possessed by an object due to its position or configuration is called as potential energy. Let us discuss the derivation for potential energy. As we know, work is written as force multiplied by displacement. But here, the force that we are going to consider is due to the gravitational force. For simple example, suppose if an object is placed at a certain height from the ground, so that object is subjected to the gravitational force of acceleration, and it is known with the weight of an object. Now in this figure, you can observe that initially the object is placed at position A. Later on, it is placed at position B. So the distance from position A to position B is considered as height h. And hence, the displacement is considered as the height between the two positions, that is h. Now, this object is subjected to the gravitational force, and hence it is written in the form of force is equal to mass into gravitational acceleration, that is mass into g, that is mg, which is then multiplied with the displacement further. So we can write mgh is the work done. Now this is the work done due to which type of energy? Exactly, that is the potential energy, which is due to the position of an object. Now we can say that mathematically, more is the height, more is the potential energy. Less is the height, less is the potential energy. So potential energy is directly proportional to the height. The formula for potential energy is mgh, where potential energy is represented with EP, and it is having the same unit as that of the kinetic energy, and that is the joule. So here we have discussed the two types of energy in detail, kinetic as well as potential energy. Now in the next session, we are going to discuss law of conservation of energy, power, and commercial unit of energy. Now we'll stop here. Thank you.